Hello everyone, today we are going to implement this rats simulation. So this is I have implemented this using a Niagara particle system. So as you can see, these rats like move to this side, move forward with some randomness to the left and to the right, and also you can see when they hit a wall, they sort of try to go around that. Not 100% accurate, but for a particle this is good enough when they are especially so many of them. So yeah, let's see how to implement this today. And I must say that these are static measures. Even though we can see animations, these all of them are static measures, not skeletal measures. Okay, so first let me import the required rat asset, that means the model and these three textures: base texture, normal map, and rat offset EXR file. So these are the types of files we need in order to implement vertex animations on static measures. So actually I don't have enough knowledge in this in the modeling side to explain how it is done, but you can refer to these tutorials. One of my friends, 𝐂𝐚𝐧𝐬𝐴, helped me with the mesh, and you can refer to this tutorial if you want to learn how to do that. So right, now let me import the mesh. Import all. Right, everything is imported. So here there are a couple of things that we have to make sure. In this in the normals, make sure sRGB is disabled. It is already disabled. And enable never stream. It is also already enabled. Right. And check the same settings. Never stream and sRGB disabled for the offsets as well. And for the model, let's go to the model. Make sure you have enabled the full precision UVs and distance field resolution as scale. Set it to 0. Right, now let's work on the material. Apply. Yes. So this is actually, we need only one material here. This is ice. So let me assign. Let me name this as rat. And since the animation will be implemented in the material, I have to use the same material, because otherwise the ice will be detached from the rest of the body if I don't have the same movement. It's not necessary to use the same material, but it's necessary to have the same movement. Right, now here let me drag and drop these three textures. This is base texture, and as the preview material I'll use the rat itself. Okay, roughness, let's set to 0. Sorry, not 0, 9. Rest seems fine. Okay, and here is the offsets and normals. So there is a node called vertex animation tools move targets. MS vertex animation tools move target. Get that. And here as the normal use the normal map, and mob texture use this EXR texture. Oh, you can't. First you have to convert these to texture objects, otherwise you can't. Right. And next thing is animations. For this you have to connect time and apply. Oh, I forgot to connect the outputs. So normal should go to normal, and the offset, 12% offset should go here, and we have custom UVs. So we already have the movement, but we have to use the custom UVs as well. So for that, UV number of customized UVs, let's set to 4, so that we can get 3 and 2. Right. Now you can see the rat has the animation. So if I add a multiplier here to the time, and as the multiply value, let's say 3. Now we can speed up with the multiplier. Another thing is, if I connect something based on particle color, maybe alpha value as this multiplier, by changing this alpha value through the Niagara particle system, we can manipulate the animation speed. Not necessarily alpha value, any value would do. Let's look into that later. Now let's implement our particle system. So I have placed few objects here to see how the rats react when they hit with an object. So under effects, we implement a Niagara system. Here I'll choose this fountain, NS rats. Place it here, slightly above the ground. So now instead of these particles, we need meshes. So let's add a mesh renderer, and as the mesh, I'll add, let me select this rat here. Rat, see. Now you get the rats, and they are being shot upwards. That's not how we need it. So let me just remove this add velocity and add velocity, a linear velocity here. Let me have a random range vector, and let's add a value like something between -100. We don't need vertical velocity, and +100. Right. Now I'll enable collision. See, now the rats are like this. They are not moving much. So next step is to move them. So for that, I'll add a linear force. Let's say 100 in the world space. So I want the rats to move in this direction. forward direction, so they are moving a bit, but not enough. Let me disable this drag. They don't have to drag, and also maybe reduce the gravity a bit too. Right now they are moving. Let's increase the lifetime 6 to 9. Right now they don't have to spawn in a single point. So shape location, this is a sphere. Let me change this to a box, and 1000 by 1000 area. Is it? I'll keep it as 1. Great. Now we have rats all over the place. And at this point they are stuck. They try to move forward and then moves back. So to prevent that, let's have some noise to this force. So before that, I think we should set a speed limit, maybe 200. Otherwise they would be too fast. Right, so adding a curl noise or a vector noise might try to move these rats vertically as well. So let's add some change in force in the horizontal plane. So this linear force, let's turn this into a mech vector, and x should be 100. We don't have to change that. Let's add y. Let's change this into a sine. Age, period scale 100. Right, it does have some change, but maybe period should be higher. Don't know, 10. And scale, let's randomize this random range float between -100 and +100. Right, now it looks better. So yeah, they don't get stuck in these points. They try to move, they somewhat avoid that, not actually avoiding that, they can pass that object. Also, let's orient these models rats towards the velocity. Right, this makes it look better instantly. Great. Now one more thing is, you can see they suddenly disappear. So that happens when their lifetime is over, they just vanish. So instead of making them disappear, let's add scale mesh size. Let's multiply this with the float and turn this float into a curve. Here this is 0. Okay, this is 1. Initially let's make it 1 and add a key. To set it to 1. Similarly, add another key maybe here. 5, value 1. Now let's see. Oh, we don't see them. Why? Yeah, maybe we have to initialize the scale. Measure scale mode. Let's make it random uniform between 1 and 1.2. Right, now we don't see them suddenly disappear. So if we want them to see for a longer range, we can let's increase the spawn rate maybe like 200, and lifetime 6 to 9 should be fine, and velocity this is also fine. Shape, if I make it 2000, okay, looks good. So if we want to slow down their animation when they are moving slowly, we can try what I said before here. Let's add another multiplier here. And 3, because that's 3 worked somewhat okay for us. Now let's add a node. Scale color by speed. Right here, source is velocity, so here use min speed threshold as 0, max speed threshold 200. I think that's the max we have. Yeah. So RGB scale, min is 0, max is 1. Alpha scale, min is 0, max is 1. Right, now this should work. See? Oh, it's too fast. Let's set 1. Still too fast. Well, I can't quite figure that out at the moment, so let me ignore that for now because it doesn't really work correctly. So yeah, I'll share it with you if I find the solution. So for now, let's keep the constant speed. Oh, I have disconnected these also. So constant speed. This is fine now. For now. Alright, so I am going to stop this episode right here, and here is the final version of the rats. Rat hood. So maybe later on we should work on some stuff like making them attract to player character or run away from player character, something like that I want to work on. And thanks for watching. As always, project files will be available for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon Club. See you in another episode. Goodbye.